Hello out there, welcome to this tutorial on differential calculus. In this video, we'll be looking at derivative of arcsine function. The function y equals to arcsine x is called the arcsine function. It can also be expressed as y equal to sine inverse of x. We now look at the formula for the derivative. Given that y equal to sine inverse of x, then the y dx is equal to 1 over square root of 1 minus x squared. This is what we are going to be using to solve some problems on the derivative of arcsine function. So we start with problem 1. For problem 1, y equal to sine inverse of x raised to power 3. Find the y, the x. So in our solution to this problem, we look at this as an entire function of x. And this is another kind of a function, which means we have function of a function here that requires the use of chain rule to find the derivative of the function. So we have the formula here that the y dx is going to be u prime over root 1 minus u squared, which means we are going to take this second function now as our u. Then we find the first derivative with respect to x, then we substitute into this formula. So we let u be equal to x raised to power 3, so that du dx, that is y prime, will be 3x squared. 3 times the function, 3x, then we reduce the power by 1. So giving us this. We can then go ahead to substitute into our formula for the derivative, so that the y dx will be u prime. Our u prime is 3x squared over square root of 1 minus x cubed squared. Since our u is x raised to power 3, this x raised to power 3 then squared. Simplifying further, we have 3x squared over square root of 1 minus x to power 6. Applying the law of indices, x3 all squared becomes 3 times 2, giving us 6. So this is the end of solution to problem 1. We then go to problem 2. For problem 2, y equal to arcsine of 1 minus x squared over 1 plus x squared. Find the y dx. So in our solution again, we still have our formula for the derivative to be dy dx is equal to u prime over root 1 minus u squared. Because this is still function of a function, in the bracket it's a function of its own. So we let u be equal to 1 minus x squared over 1 plus x squared. Then we find the derivative, du dx. So du equal to 1 minus x squared over 1 plus x squared requires the application of quotient rule to find its derivative. So, normally, this is the numerator, this is the denominator. Has it been we don't have this u, we would have said u over v. So we can just say m over n. So what we'll do is to keep the denominator, which is 1 minus x squared. Then we differentiate the numerator. The derivative of 1 is 0. So we now have the derivative of minus x squared, which is going to give us minus 2x. You multiply the 2 by the negative 1, giving us negative 2, reduce the power by 1. We have it as x. Then minus, since we held the denominator in the first place, this time around we are going to hold the numerator, 1 minus x squared. Then we now differentiate the denominator. Okay, so 1 plus 2x squared, the derivative is 2x. Because the derivative of 1 is 0, x squared, the derivative will be 2x, which we have here. Then over the denominator squared, 1 plus x squared all squared. We can then go ahead to expand the numerator. Negative 2x times 1 gives negative 2x. Negative 2x times x squared gives negative 2x3. We are done with the first part. Then the second part, remember this minus will be used alongside with these 2x to expand the bracket. So we can say negative 2x times 1 gives negative 2x. Then negative 2x times negative x squared gives plus 2x cubed, then over our denominator. We simplify the numerator. This minus 2x minus 2x, this is minus 2x3 plus 2x3. So since this is minus 2x3 and this is plus 2x3, they cancel out because simplifying them will give us a 0. So we are now left with minus 2x, giving us minus 4x. Then divide by 1 minus x squared all squared. So we've gotten our u prime. We can then go ahead to find our dy dx. Our u prime, which is negative 4x over 1 plus x squared all squared. If I separate this now, I can say u prime times 1 over square root of 1 minus u squared. So that's what I'm going to use for easier manipulation. So I will say times 1 over square root of 1 minus, what is our u? Our u is this. So we have it as 1 minus x squared over 1 plus x squared. Remember, it is all squared, so we have it to the power of 2. Remember, the square is only affecting this rational function. So we go ahead now to simplify. This is minus 4x times 1 giving us minus 4x, then over 1 plus x squared all squared, then root 1 minus x squared over 1 plus x squared all squared. Is it possible we leave it like this? Because we can still simplify further. If we simplify further, we are going to have minus 4 over 1 plus x squared root 1 plus x squared all squared minus 1 minus x squared all squared. This is it. Okay, what I did here is to make what we have inside the square root a single fraction, which we now carry 1 plus x squared all squared as the denominator, and its square root will just give us 1 plus x squared, which we remove one of this. Since we remove one of this, I will now be left with 1 plus x squared, which means the denominator has gone. So I'm only left with making it a single fraction. I have 1 plus x squared all squared minus only the numerator here squared, which is 1 minus x squared all squared. And that's all for the solution of this problem. And this is where we are ending this tutorial. Thank you for watching. I hope you enjoyed it. Please like and share this video. Until we come your way again, goodbye.